Find the average value on the interval 0 to 3 inclusive for f of x equals x over quantity x squared plus 1 square rooted. Okay, so average value, the way I like to think of average value, well, let's start with the formula. Formula 1 over b minus a integral f of x dx, complete the f, go from a to b. Okay, so this is the formula, but the way I like to think about it, because I'm not very good at memorizing formulas. I'm not very good at memorizing in general. But the more I can think about a formula and what it means, usually the easier it is for me to recall it. So this is f of x, and this is the area under f of x. Then what the average value in effect kind of means is if you take this equation and squish it down so that it's a rectangle with b minus a, and what you're looking for then is this height right here. That would be the average value. So what you're doing is you're basically taking the area under the curve and then squishing it so that it's square. Well, rectangle. Filled with many squares. No, rectangle is probably just the best way of phrasing it. So this is what we're going to do. And so first thing we do is find the area under the curve, which integral, and then we'll divide by the distance that the integral covers. So another way of saying distance is b minus a. So the distance between a and b is b minus a. Okay. So on to the integral. I'll do it this way. So I'll start by rewriting it. That gives me time to focus and kind of feel my way through this to let the spider senses activate. So we see here that we have one thing that's a derivative of another. So we take this, take the derivative, and we're going to get something kind of like x. So this is most likely going to be a substitution. So u equals x squared plus 1, du equals 2x dx, du times 1/2 equals x dx. Okay, now we're ready to substitute. Bum bum bum. Integral, let's see, 1/2 x dx, which gives us the du, x squared plus 1, that's u to the 1/2. Rewriting it one more time so it's more obviously the power rule, integral u to the negative 1/2 du. Now there are limits to this, so this will be from 0 to 3. Now when we substitute in for u, we're going to get something different. That's why I leave the limits of integration blank, but I'll go back to x and then try and solve it for x. It's usually, for me, easier to just keep everything straight when I do it that way. You can do it how you feel, though. So u to the 1/2, we do negative 1/2 plus 1. And then we multiply by the reciprocal, which would be 2 over 1, which cancels nicely with the 1/2, which gives us u to the 1/2, which will be x squared plus 1 evaluated at from 0 to 3. Okay, so this is going to be the area under the curve. This is not the average value. This is the area under the curve. So we will have x squared, so it will be 3 squared plus 1 minus 1. Oh no, there's a square root involved. Whoop, square root. There we go. Square rooted, square rooted. So this gives us square root of 10 minus the square root of 1. Square root of 1 is just 1, so I'll simplify that to 1. So our area of the curve is this. Therefore, the average value will be the area divided by the distance or width. So you have your curve looks like this. Area under the curve is that. The rectangle will be this. So we'll divide by b minus a, which is 0 and 3. So 3 minus 0 is 3. So average value, that is a terrible average value, but I said it so you can read it because you know what it says. volume? No, that's terrible. Square root of 10 minus 1 over 3. Because 3 is the distance or width of this rectangle. Whoop, whoop, put it over here. Aha! We even have it as a possible answer, which is nice. Right there. So the average value of f of x in this case will be square root of 10 minus 1, because that's the area. And divide by 3, because that's the distance or width of our interval. So I approach this problem. Hope it helped you guys. Go team.